Copy this from problem. All of you go through the problem solution. A simply supported beam is 120 mm by 300 mm in section. Okay, the cross section of the beam is given as 120 by 300, has a span of 10 meter. Okay, let me read the cross sectional dimensions. Cross sectional dimensions is 120 by 300 mm. 120 by 300 has a span of 10 meter. Total span of the beam is 10 meter. (10 meter) is the span of the beam. Is pre-stressed by a parabolic cable which has a maximum eccentricity of 100 mm at midspan and minimum eccentricity of 20 mm at the supports. First write the neutral axis. What it says is 100 mm at the midspan and 20 mm at the supports. At support 20 mm and at midspan 100 mm. And it's a parabolic cable like this. Okay, at the supports the eccentricity is 20 mm and at midspan eccentricity is 100 mm. So here also 20 mm. Okay, then the effective pre-stressing force in the cable is 300 kilonewton. Pre-stressing force P is given. P is given as P is equal to 300 kilonewton or 300 into 10 power 3 Newton. Okay. The beam carries all inclusive UDL of 30 kilonewton per meter. All inclusive UDL means including the self weight of the beam and live load of the beam, the total load. Okay. Total load, it is given as 30 kilonewton per meter. Okay, 30 kilonewton per meter. Okay. Therefore, the factor load will be equal to total load is all inclusive load is given as 30 kilonewton. Therefore, the factor load is equal to factored load is equal to 30 into 1.5, that is 45 kilonewton per meter. Okay. Determine the principal tension at 0.6 meter from left support. Okay, it's a quite different problem. So we have to find principal tension. It means principal stresses. Okay, at a distance of 0.6 meter from the 0.6 meter from the left support and 20 mm above the neutral axis, somewhere here at this point. At this point, you need to find the principal tension value. Okay, that is the question. That is the question. Okay. Now, what is the formula we have to find the principal tension? Just before we have seen our principal stresses. The formula what we have is, this is the formula fx plus fy whole divided by 2 plus or minus half of fx minus fy whole square plus 4 tau v square is the formula. Okay. So we need all these things. First we'll find the tau v value, that is shear stress value. Okay. Later on we will find fx value, fy value, substituting all the things, we will get the principal tension value. Okay. Now to find tau v, what is the formula? We have tau v is equal to Vu into Ay bar divided by Ib is the formula. Vu into Ay bar whole divided by Ib is the formula for finding the shear stress. Okay. Now we will go on finding one by one Vu. First we need the value of Vu, shear force. Okay. So just as we determined in the previous problems, in the same way we need to find the Vu value here. So Vu has to be determined at a distance of 0.6 meter from the left support. Okay. Now, first you find the reaction at the supports. Total load that is acting on the beam is 45 kilonewton per meter. (45 kilonewton per meter) acting over a length of 10 meter. 10 meter. Okay. Therefore, reaction is equal to WL by 2 is equal to 45 into 10 divided by 2. If you calculate, you will get it as 225 kilonewton. Okay, that is in upward direction, upward reaction, or 225 into 10 power 3 Newton. Okay, this is the shear force due to the load. Okay, shear force due to the load. Along with this, we should also find the vertical component of the pre-stressing force. We should also find vertical component of the pre-stressing. Okay. Now we have to also take into consideration the effect of the pre-stressing force also. Okay. Now it is asked to find the principal tension at a distance of 0.6 meter from the left support. Okay. So therefore, at this point only we need to find the, so here the pre-stressing force will be there. We need to find its vertical component at a distance of 0.6 meter from the left support, not at the extreme edge of the support. Okay. So for that, the calculation is different. Okay, first you write the figure, cross section of the beam you write. Okay, write the neutral axis. Neutral axis, this is the neutral axis. Okay. And in the question it is clearly mentioned to find okay, from the neutral axis, it is asked to find the stresses at a distance of how much? 20 mm above the centroidal axis. 20 mm above the centroidal axis. Okay. Now you draw a dotted line here at a distance of 20 mm from the neutral axis. Okay. So while finding the moment, no, we have to find the moment of the shaded portion above the dotted line which is drawn at a distance of 20 mm from the neutral axis. Okay. Now I'll write the cable profile separately, which is required to find the value of sin theta. Okay, which is required to find the value of sin theta. Okay. So it is asked to find the stresses at a distance of 0.6 meter from the left support. You draw a section at a distance of 0.6 meter from the left support. Zero point 0.6 meter from the left support. Okay. Now we have to find slope at this particular point. You have to find slope at this sin theta value at this particular point. So whatever the formula we have for parabolic cable, okay, that is for finding the slope at the support only. If you want to find slope at some other point, so we have to follow the basic principle. Okay, we have to follow the basic principle to find the value of slope. Okay, let us see how to find that. See, this cable is, see this cable, the end of the cable is at a distance of 20 mm from the neutral axis. Okay, 20 mm from the neutral axis. I'll write the diagram of the neutral axis also here at the top. Okay, so here it is. This distance is 20 mm. Okay. The eccentricity at the midspan is 100 mm. Total eccentricity at the midspan is 100 mm. Then eccentricity at the support is 20 mm. 20 mm. Okay. Therefore, the height of the cable from this dotted line will be how much it will be? This length. Actually, this height is required. H is equal to 100 minus 20. 100 minus 20, which gives the answer as 80 mm. 80 mm. Okay, H is equal to 80 mm. We will get the value as 80 mm. Okay. So using the equation of the parabola. Okay, what is the equation of the parabola? Y is equal to 4hx by L square into L minus x. Okay, using this equation of the parabola, we can find the slope value. See, why we are following this basic principle is whatever the formula we have, that is 4e by L sin theta is equal to 4e by L. It is at the support. It is at the support. But here in this particular problem, it is asked to find the principal tension at a distance of 0.6 meter from the left support. Therefore, at this point, if you want to find, you have to follow this method, equation of the parabola. So y is equal to 4hx by L square into L minus x. I can rewrite this formula as y is equal to y is equal to 4h by L square into Lx minus x square. Lx minus x square. Okay. Now you can find the slope. Differentiate with respect to x. Okay. Differentiate with respect to x. Therefore, dy by dx is equal to 4h by L square into L minus 2x. L minus 2x. What is dy by dx? Dy by dx is nothing but slope. Slope is nothing but sine theta. Sine theta is equal to 4h by L square into L minus 2x. Now, if we substitute, if you want to find the slope at a distance of 0.6 meters, substitute x is equal to 0.6 meter in this equation. Okay, wherever you want, you can find the slope now. Okay, therefore, at a distance of 0.6 meter, see h is equal to, just before we have determined h is equal to, it is 80 mm. 80 mm. Then length of the beam, total length of the beam is given as 10 meter in terms of mm. It is 10,000 mm. Then x, we are interested to find slope at a distance of 0.6 meter. The substitute everything, you'll get the value of sin theta. Sin theta is equal to 4 into 80 divided by 10,000 square into 10,000 minus 2 into 0.6 meter or 600 mm. 2 into 600. 2 into 600. Therefore, sin theta value is equal to, it will be 0.028. 0.028 is the value of sin theta. Okay. Now we got the value of sin theta. Then we know the reaction at the support. Okay. We know the reaction or the shear force due to the load. We know. Then we know the value of sin theta. The vertical component of the precessing force is equal to, therefore, vertical component is equal to P sin theta is equal to P is nothing but how much? Precessing force. It is given in the problem. It is given as 300 kilonewton. P is given as 300 kilonewton. So 300 into 10 power 3 Newton. 300 into 10 power 3 Newton into sin theta value is 0.028. 0.028. Okay. So if you calculate the answer, you will get the answer as 8,400 Newton. Okay. And remember this P sin theta. P sin theta, vertical component of precessing force, will be in downward direction. Be careful about the directions because based on the direction only you will adopt the sign, no? So it is downward direction 8,400 Newton. Now we can calculate the net shear force. Therefore, net shear force is equal to you add both the values 8,400 and shear force due to the load. Okay. Shear force due to the precessing force is 8,400 Newton downward. Shear force due to the load is 225 into 10 power 3 Newton upward. Adding together, we'll get the net shear force. So it is 225 into 10 power 3. 225 into 10 power 3 minus 8,400. Minus 8,400. Okay. Final answer is 216.6 into 10 power 3 Newton. Okay. So this is the final answer of the VU. Okay. 216.6 into 10 power 3 Newton. Now we got the value of VU. What next? You need to get the value of AY bar. Okay. static moment of area. Correct? Static moment of area Ay bar is equal to Ay bar is equal to Ay bar is equal to, see, refer this figure, students. Here the total height will be, neutral axis will be half of the total length, 150. 150. So 150 minus 20 means how much? It will be 130. Area of the shaded portion 130, and width of the beam is 120 mm. 120 mm means we need to find the static moment of area of the shaded portion. What is the area of shaded portion? 120 into 130. A is how much? 120 into 130. 120 into 130 into y bar. Y bar is nothing but distance of centroid of shaded portion from the neutral axis. So it is 130 by 2 plus 20. Correct? So y bar is equal to, let me write that calculation. How much it is? 130 by 2 plus 20. 130 by 2 plus 20. Correct? So this is the value of y bar. So if we calculate the answer, Ay bar value will be, therefore Ay bar value will be equal to Ay bar value, that is static moment of area, is equal to 1.326 into 10 power 6 mm cube. Okay, 1.326 into 10 power 6 mm cube is the answer. Okay, then moment of inertia is there. Okay, Ay bar we got, Ib is there, no? I is nothing but moment of inertia. I is equal to BDQ by 12. BDQ by 12. So width of the beam is given as 120, depth is given as 300. So 120 into 300 cube divided by 12. Okay, answer is 270 into 10 power 6 mm to the power of 4. Mm to the power of 4. Okay, then B is equal to how much? B is equal to 120 mm. B is equal to 120 mm. Therefore, the shear stress tau is equal to Vu into Ay bar. Vu into Ay bar divided by Ib is equal to Vu is equal to how much we got? 216.6 into 10 power 3 Newton. 6 into 10 power 3 Newton. Ay bar value 1.326 into 10 power 6 divided by Ib. 270 into 10 power 6 into B is 120. Okay. The final answer is tau V is equal to 8.86 Newton per mm square. 8.86 Newton per mm square. Okay. Now you got the value of tau V. You got the value of tau V. Now what else you required? You require Fx and Fy value. You try to calculate Fx and Fy value now. Take 1 minute time to calculate. Try to calculate the value of Fx and Fy. Fx is nothing but horizontal pressure, okay, which is equal to force by precessing force divided by area, and Fy is nothing but vertical pressures, Fy. Okay, you calculate both the values. Tell me the value of fx and fy. Horizontal pre-stress fx is equal to, it's a very simple calculation, correct? Horizontal pre-stress fx is equal to directly force by area, pre-stressing force divided by cross-sectional area. Pre-stressing force is how much? How much it is given? Pre-stressing force 300 kilonewton is given. So 300 kilonewton, nothing but 300 into 10 power 3 Newton. 300 into 10 power 3 Newton divided by the cross-sectional dimensions of the beam is 120 by 300 divided by 120 by 300. So if you calculate the answer, you'll get the answer as 8.33 Newton per mm square. 8.33 Newton per mm square. Okay. Then the vertical pre-stress. Vertical pre-stress. There is no vertical pre-stress mentioned here in this problem. Fy equal to, you can take it as 0. Okay. Now you can calculate principal stresses. You can calculate the values of principal stresses. So we know the formula. Okay. Here in the problem, what is mentioned? Principal tension, nothing but principal stresses only. Okay. Therefore, sigma max or sigma minimum is equal to fx plus fy whole divided by 2 plus or minus half of root fx minus fy whole square plus 4 to v square, 4 to v square. Okay. First you find sigma maximum is equal to fx plus fy whole divided by 2. Fx plus fy whole divided by 2. Fx is 8.33 plus fy is 0 divided by 2 plus root of 8.33 minus 0 whole square plus 4 into tau v, shear stress 8.86 square. 8.86 square. So sigma max is equal to, please cross check the answer, it is 13.95 Newton per mm square. 13.95 Newton per mm square. And sigma minimum is equal to 8.33 plus 0 whole divided by 2 minus 8.33 minus 0 whole square plus 4 into 8.86 square. Okay. Sigma minimum is equal to it is minus 5.63 Newton per mm square. Minus 5.63 Newton per mm square. Okay, to this the solution of this particular problem is over. So if you have any doubts in any point of the calculation, you can ask. Okay. Thank you.